MAP4C 4.5, the use and misuse of data. When we're conducting statistical research, what we're trying to do is investigate some population, so all members of some group. And it can often be time-consuming, challenging to access every single member of a population. So what we do is take a smaller group, just a selection of some of these members, and we call that group the sample. And we use this sample to try to draw inferences about this population. So this smaller group gives us statistics about this population. Could be the mean or standard deviation. And the population has a true value if every member is included. We call these parameters the actual mean and standard deviation. We could use this group to make this prediction about the population and be pretty accurate depending on the following features. So we need to assess the sample group. Was the sample representative? So a sample is representative if it has qualities that are similar to the population, meaning that the proportion of members in the sample are similar to that of the population. So the sample size must be large enough. In small sample groups, we can have a lot of fluctuation in regards to the statistics that are representing the population. So a larger sample will be a more reliable research. We're getting closer to the actual values of the population. Next, we need to think about the sampling technique. The sampling technique is the way in which you've selected members of the sample. And if you've selected these members randomly, hopefully it has it's a good representative sample for the population. Assessing data collection. Was the survey question biased? So the way that the information is gathered can affect the outcome, and if it's not done in a fair way, a biased way, then the conclusions drawn from that research will not be valid. We've learned that biased survey questions can be leading or loaded questions, and they influence the respondent to answer in a particular way. So we try to remove any additional information other than simply the question in order to make sure that the respondent is giving their honest answer. So was the sampling method appropriate? So the way that you ask the question can affect the responses. People who know that they're being observed might behave differently than if it was a random or anonymous survey. Whether someone has an open or closed-ended question, meaning they can give an open response, or if they're given a selection. And if they're given limited options, then the researcher has either intentionally or unintentionally led those respondents to particular answers, and that would invalidate any conclusion drawn from that research. The next component to look at is the way in which the data is being presented. Think about the incentives of the researcher. If there is a benefit to presenting their findings in a certain way, it's most likely that they will try to represent the data in that format. So let's take a look at these two types of graphs and see how they can be manipulated in order to exaggerate certain characteristics. So the appearance of data may be misleading when presented using different dimensions. These two graphs appear different, but represent the exact same information. So this is talking about the distribution of ages for Canadians in 2001. So let's take a look at this section here. From age 25 to 44, 24% of the population falls into that range. But the 3D graph, from this perspective, the sector for 25 to 44 looks much larger than this overhead two-dimensional view. So the graph on the right-hand side is more accurate in its representation of this data. So both represent the same information, however the 3D model affects perception. Next, another factor to consider is an axis break. So an axis break happens whenever you have a continuous set of values for our y-axis. In this case right here, you can see that the y scale is every one grid space represents 0.25 units, because if this is a half of that is 0.25. And then on the left-hand side, we have one grid space. If this is one whole, then this is half. One grid space represents a half, or 0.5. So y scale can affect the representation of this data because this is the same information on the left and right hand side. But this break in the line can affect the way that this is presented. Notice that this looks much more steep on the right hand side even though it's the same information. And the way that that illusion is accomplished is by starting off the y-axis really close to where the first data value is. Notice that it doesn't show a line break, but it's starting approximately around 4.2. This makes it look like it's increasing rapidly. This should have started off at 0 and went up one by one. If you show this entire section here of the y-axis, everything from 0 up until the first value, you get a better perspective on the overall change over time. And here it looks less gradual. So this is the type of technique that you might see the media use for headlines to say a rapid increase in company profits using this format, because it might help people, maybe it'll help their stock if people believe that the company is going to do well. So think of the incentives of the researcher, and that can help you determine whether or not this might be valid research. Next, assessing the validity of a conclusion. A valid conclusion is one that is supported by unbiased data that has been interpreted appropriately. So, good research exists, but I want you to be critical of the components that we've discussed when analyzing statistical research. Are the data reliable? So if it is an unbiased researcher, it is more likely to be reliable data. Is there a possible bias in the person analyzing the data? If there is a possible bias in the person analyzing the data, then they may just be looking at the cases that are favorable to the outcome that they desire, that would be beneficial to them. So be aware of that. Is the correlation strong? So, in correlational studies, the relationship between two variables, if we have a regression model, such as a linear model or line of best fit, where the data points are tightly packed around the line of best fit, then there seems to be a strong correlation, and that we can use that model to make predictions both within the data with interpolation or outside of the data using extrapolation with more confidence. It's more likely to be true. Is there any evidence to support a cause and effect relationship? So this is where being an expert in the topic might help you identify external factors that could also be contributing to each of these variables in a correlational study. Next, does the graph represent the data appropriately? So think of the way that this is being presented, and is there any way that the facts are being distorted or in its representation?